right, so I am here for the first live coding of 52 weeks of live coding MLOps stream here. And I thought I would just start doing some live coding of things that I'm working on currently. So this summer happens to be an unusually big summer for me for projects that I'm working on, and it's all mostly in the MLOps space. So I'm working on a course right now with Coursera and Duke on MLOps. I'm teaching an MLOps course at Duke in their AI product management uh, program, and I'm also building a lot of content around different types of certifications for machine learning. So in my past, I've done work with the AWS machine learning certification. I had that certification. I've done work with the Azure machine learning certification, which is associate data science. I've also worked with the Google Cloud quite a bit, and I'm working on some material for the Google machine learning certification. I've done work with the Databricks, certification as well in terms of machine learning. So I figured I would just really have a kind of a brainstorming session each week where I talk a little bit about the areas of research that I'm investigating or doing things with, and then just start writing some code and showing people, my thought process. So really, to start off with, probably a good place to begin was just some things I've been taking a look at recently. And so I'm going to share my screen. I'm going to talk a little bit about TensorFlow to begin with here. And let's go ahead and do that. Let's share the screen here. And so, yeah, here we go, TensorFlow. And so from an MLOps perspective, there's a lot of talk about MLOps right now. I think, it's important to define what it is. And really, MLOps in most cases is end to end. That's really what you're trying to talk about. People can talk through all kinds of complexities around what is or isn't MLOps, and there's many different subcomponents of it. But in a nutshell, what it means is that you can get your model to production and do something with it, and that's why the end-to-end definition is a pretty good definition for MLOps. And so if we take a look at TensorFlow here, TensorFlow is probably the most popular deep learning framework. And if you look at the kind of the direction that they're pushing people to, they start off with this concept of an end-to-end open source machine learning platform. And so let's go ahead and just follow along and see what's happening here. So TensorFlow is the core open source library that helps you develop and train ML models, but also you can get started by running the Colab notebooks directly in your browser. So I will point out that I am a huge fan of Colab notebooks, and I do use it extensively for many kinds of things that I'm working on. And also, though, be aware that that's not the only way to use TensorFlow. You can also do JavaScript. And so in this example here, you can also use JavaScript for training and deploying models. You also can do mobile and edge. And I've actually done a lot of work with mobile and edge for TensorFlow. And the reason that it works pretty well is they have this thing called TensorFlow Lite, and it works with mobile devices, microcontrollers, and other edge devices. In particular, there's this device here, which is called a Coral device. And this Coral device actually can run TensorFlow Lite models. And I'll probably run this at some point in the next few weeks and show people how it works. But that's one of the really nice things about TensorFlow is it's got a whole ecosystem where you can do it in Notebook, you can do it in JavaScript, you can put it onto an edge device like a microcontroller, put that in some location that's hard for a laptop to be or a workstation, and actually do inference, and then production, right? So TensorFlow Extended is an end-to-end environment. So let's just take a look at all of these today and kind of kick the tires here. So first up, we got TensorFlow, and let's go ahead and open this up into a new tab and see what it does. So it says, here we go, TensorFlow end to end. Here's the beginner stuff here. And in fact, we can actually go through and use the beginner model here, which is the Hello World model. So let's go ahead and click on run code. And what this is going to do is going to provision a Colab environment. If you're not familiar with what Colab is, it's a hosted runtime that actually has some really neat features associated with it. And I'll show you what those are. So first, you can connect to it like this. And notice that it has this option, connect to hosted runtime. So let's go ahead and click that. What's going to happen is that it's going to allow me to now run this in the cloud. Notice I can hover and it will tell me basically that I have a total of 12 gigs of RAM. I have a disk that's 225 gigabytes. Now I can change this though as well. So if I go to runtime and I go to change runtime type, I can actually use hardware acceleration. So I can use either a GPU or a TPU. I'm going to go ahead and select GPU. TPU is a TensorFlow processing unit. I'm going to select GPU. And I also, if I want to, if I have the pro version, which I do, I pay like $10 a month for it, I can get a higher RAM. So depending on what it is you're doing, it may actually be worth this from a research perspective. It's not that expensive. It's a lot cheaper than buying, some huge GPU for your workstation. So if we take a look at this, another thing to point out about the Colab notebooks is that if we go here and we look at this table of contents, every time you have a hashtag, it will create a hierarchy that will show up in this table of contents. So this is a really cool feature of Colab that is nice, because if you're going to do this yourself, you could build out a structure like ingesting the data, exploratory data analysis, conclusion, etc. So what I'm going to do, because I'm going to be working on this for the whole summer, is, or potentially even longer than that, is I'm going to go ahead and build out a new repo, say new, and I'm going to say 52 weeks MLOps, and I'll just start checking some things inside of here. Just say, this is for the live streaming week. Here we go. And then I'll just go ahead and add a README file, and I'll also add a git ignore for Python. And then I'll go ahead and say create repository. There we go. So I've gone through here and I've created this repository, and now I can just take the beginner notebook here. This is a neat little feature of the Colab environment, is I can say save a copy in GitHub, and then I can just save this particular notebook inside of my repository, and I can share it out with other people. So really this is the part of the ecosystem and why it's so cool. I'm going to go down to 52 weeks here. Don't know exactly where that will show up. I don't know where the numbers and the letters begin here. I guess 52 weeks shows up before. Here we go, 52 weeks of MLOps, perfect. And we'll go ahead and check that in. It creates a copy in there, perfect. So other people could take a look at this. But really the first thing to do is that TensorFlow has Keras, which is the higher level interface. And this is going to load a pre-built data set. It's going to build a neural network that classifies images. It's going to train this neural network, and it's going to evaluate the accuracy of the model. And so this particular tutorial is a Colab notebook, as we mentioned. I went through and I enabled this fancy runtime here, which you can see I have 25 gigs of RAM, and I'm also connected to a GPU. So the first thing to do would be to import TensorFlow, right? This is our machine learning framework. We got this thing working. Next up, this is kind of a classic, way to test out something, is the MNIST dataset, which is really predicting handwriting. So what's nice is that they give it to you. It's already included with TensorFlow. So as long as you've got a TensorFlow loaded, you just say MNIST, say tf.keras.datasets.mnist, and then you just say mnist.load data, and then you build out your train and your test set. And the training data is where you would basically train your model. The test would be after your model is trained. That separated data is where you would verify that your model is able to do the predictions on. And so once we've gone through this, you can see we download the data real quick, very, very fast. And then now we can build the machine learning model. The way it works with Keras is actually pretty nice because it allows you to have a very high level interface to build a deep learning model. So first we have a model here, which is tf.keras.models.sequential. We do tf.keras.layers flatten, and here's our input shape. We do tf.keras layers dense, and we have an activation function, which will be the ReLU activation function. We have a layer that is dropout, and we have a layer that's dense. Let's go ahead and run this. Here we go. And this is going to then set this up for us. Now that I've got this defined, I can say for each example, the model returns a vector of logits and log odds scores, one for each class. And so if we go through here and we run this, we can go through and look at the results here. And now this tf.nn softmax function converts these logits to probabilities for each class. Here we go. And notice that this is now a NumPy array. And we could even take a look at this if we wanted to and say, result or something like this, and then make a cell below here and say, basically type result, and just we could see what kind of data type is returned, and we see that it's in fact numpy.nd array. So that's another thing to be aware of. So note that it's possible to bake the tf.nn softmax function into the activation function for the last layer of the network, and this can make the model more directly interpretable, but it's discouraged because it's impossible to provide an exact and numerically stable loss calculation for all models when using a softmax output. So if we go through here and we say loss, we go through, we can say this loss is equal to the negative loss probability of the true class. So basically we're trying to figure out what the accuracy is. And then it says before you start training, configure and compile the model using Keras model compile. We'll go ahead and compile this. And now we're ready to do fit to minimize the loss. So the idea here is that we train it on this data to minimize the inaccuracy of the model. And we can see that basically the loss itself is being reduced at each epoch or each iteration, and it's getting better and better accuracy. And so we can see here that it did 5 epochs here because that was what we passed into the model.fit. And then if we do model.evaluate, this will go through here and it will check the model's performance on the test data, right? So this is what we pulled out at the very beginning here. We see that the accuracy here is 0.97. The image classifier basically has essentially 98% accuracy to predict the handwriting. And if you want to return a probability, you can also do that as well. And this will show you basically the probability of each of the testing. So we've got the pre-trained model here. And so that's fortunately the training is pretty straightforward. So that's the TensorFlow. But what if we go to production now? Because this is what I wanted to cover, was doing MLOps. Well, let's go ahead and click on getting started with TensorFlow Extended. And so it says TensorFlow Extended is an end-to-end platform for deploying production ML pipelines. Let's say we're ready to move from research to production. How would we do this? Well, we could, in this case, fortunately, just run it right into Colab. Let's go ahead and play around with this. So we see here's a whole setup here. We can go through. So this is a simple TensorFlow extended pipeline using the Penguin dataset. And so we can do the same thing. Let's go ahead and connect this to a hosted runtime. I'm going to go ahead and pick runtime. I'm going to make it a high RAM, and I'm also going to go to GPU, and I'm going to go ahead and say save. And so we can manage the session. We can terminate the other GPU session, and we can terminate that one as well. There we go. So we've only got one running, and we'll reconnect. And we'll go to runtime, make sure everything's set up. Perfect. Okay, so we got this thing working. It says we recommend running this tutorial in a Colab Notebook with no setup required. Just click run in Colab Notebook. So in this example, we could, it says the first thing we need to do is install the TFX Python package and download the dataset we'll use for a model. So we want to avoid upgrading pip in a system when it's running locally, and we want to check to make sure we're running in Colab. So let's go ahead and do this. We'll say try import Colab. If that works, we're going to upgrade pip. And we can see here that I believe we uninstalled version 21.13 and we went to 22.04. Now we can go ahead and we can do pip install the TFX. Let's go ahead and do this. And it says, there we go. So there's a lot of code to install this hosting runtime. And once we do that, we should be able to go to the next step. So you can see it's installing like PyArrow, PyMongo, protobufs. There's a lot of goodies inside of this TensorFlow extended that are used to run TensorFlow models. So let's go ahead and keep running this thing. Keep going, and there we go. So it looks like it may have worked. It says successfully installed Apache Beam. There's some couple incompatibilities, but it says, okay, now if you're using Colab, the first time you run the cell above, you must restart it by clicking restart runtime. This is because of the way that Colab loads packages. Okay, so let's go ahead and do this. We'll go to runtime and we will go to restart runtime. Let's go ahead and do that. And so now that it's been restarted, we should be able to check the TensorFlow and TFX versions. Let's go ahead and run this. Import TensorFlow STF. Perfect. And we also are able to import the version here. So the next thing we're going to do is set up the variables. So these are some variables that are used to define a pipeline. So you can customize these variables as you want. So we have a pipeline variable, we have pipeline root, we have the metadata, the serving model directory. So this makes sense to me that you want to set these up so that your ability to serve out models is going to go through those variables. And then we're going to download the examples for use in the TFX pipeline. So the dataset we're using is the Palmer Penguins dataset, which is also used in other examples. There are 4 numeric features in this dataset: Coleman length, Coleman depth, flipper length, and body mass. All these were also already normalized to be between 0 and 1. And this classification model will predict the species of penguins. So here we go. First up, the TF examples reads an input from the directory. So we need to create a directory and copy the data. So we're going to use this temp file code here that makes this temporary directory. And then we go ahead and we retrieve this data. If we look at the CSV file, you can see here's our data right here. You should be able to see 5 values. The species is either 0, 1, or 2. And all the features should have a value between 0 and 1. And I think that is in fact correct. Now let's go ahead and create a pipeline. So with machine learning and also data operations, DevOps, all of them are about actually creating pipelines. And in this particular scenario here, we're going to use a TFX pipeline, and we're going to use the ability to read in data files and convert them to TFX internal format. We're going to train an ML model, and then we're going to copy the trained model outside of the TFX pipeline. And this pusher component can be thought of as a deployment process of the trained model. So first up, let's write the model training code. So we're going to create a simple DNN model for classification using Keras. So this will be similar to what we did before. And so in this tutorial, we use the generic trainer, which supports Keras, which is nice because it's simpler. And we're going to write a Python file containing runFn function, which is the entry point for the trainer component. So first we have this trainer module file called Penguin Trainer. Now, this is a cool little feature that I use myself, is that you can actually write out a script file inside of a Jupyter Notebook or Colab Notebook by doing this magic function, which is %% write file. And this will go ahead and write this out. Once we've written this out here, this trainer file, now all we need to do is then run it later. So now we've built a complete preparation step here. So you can see here that, it does training. Here's our run function, all this stuff. And now we write a pipeline definition. So we define a function that will create a TFX pipeline. The pipeline object represents a TFX pipeline, which can be run using one of the pipeline orchestration systems that TFX supports. So we will bring the data into a pipeline right here. We'll use a user-provided Python function that trains the model. We'll push the model to a file system destination, and then we will follow 3 components to be included in the pipeline. So let's go ahead and run this code. There we go. And now to run the pipeline, TFX will support multiple orchestrators to run pipelines. In this particular example, it'll be local DAG runner, which is included in the TFX Python package and runs pipelines on a local environment. We call this TFX Pipelines DAGs, which stands for Directed Acyclic Graph. The local DAG is a fast iteration for development and debugging, and it also supports things like Kubeflow pipelines and Apache Airflow pipeline. So we can create this local DAG and pass a pipeline object to it, right? So here's now we're getting into pipelines. Now, did I not run something? Let's see, I ran this. That appears to work. And this is saying that the model runs directly. We should see the progress of the model. And so what does it say here? This file is not defined. So I need to double check that I ran this file up here, which I believe I did. Maybe I didn't run the one above it. And now we can go back here, and okay, that's all it was. So now we see that the orchestration system is using that script that we wrote to basically orchestrate the training of the system. So that is pretty cool. This is not a lot of code, right? To build out this a pipeline. And then now that we've got this work, we can basically say you should see info component pusher is finished, which is the last step that we said. It said at the end, the logs if the pipeline finished successfully because the pusher component is the last component. Now the pusher component pushes the trained model to the serving model directory variable, what we set up before, which is the serving model penguin simple. And if you don't change the variables, you can see the result from the file browser in the Colab. So we can go over to here. We can go to this file section here, and we do see that under serving model, we have our penguin model right here, which is going to be the save model.pb, the Keras metadata, the variables, and the assets, right? So create a nice structure for us to use to serve out the model. So I think this is something that we're seeing a lot now, is that there's like a hierarchy inside of a lot of the serving frameworks for machine learning. So MLflow has this as well. The SageMaker has this. There's a whole directory of different things. It's not just like the serialized model. It's actually the metadata associated with it, right? Which in this case would be the Keras metadata, the variables, the assets associated with it, right? And so we can go ahead and run this and see the same thing. So now that we've been able to crave that out, we should be able to serve that model out by using whatever mechanism. So we can see here, let's go ahead and look at the tutorial. So it says TensorFlow in production. Again, I've never used this before, but it says the best way to use it is by learning. So you build this, add it, and then once you have the basics of it, there must be a step here where you serve the model out. So let's go ahead and click on serve the model. And so this is train and serve a TensorFlow model with TensorFlow serving is, I believe, let's go ahead and run this. So now that I've got that understood, let's see if I can get this run in like 5 minutes here. I'm going to go to change runtime type. GPU, high RAM, save it, connect to it. It might make me kill the other session, which is fine. Let's go ahead and terminate this, and let's go ahead and take a look at how this works. So first step, we go through and make sure TensorFlow is working. We import the MNIST data here. We train the model. Let's go ahead and do that. This should take just a second. Once we train the model, let's go ahead and double check this thing. There we go. This is epoch 1. I think we got to go through 5 epochs. Then we should be able to save the model so it's in the right format. So just give this a second. This should be pretty quick because we have the pro version. Okay, that looks good. All right. Now that I've saved it, here's accuracy, or we've trained it. Now let's save it. That should persist it out to disk, which we should have this structure on disk here. And now if we looked at the saved model, you should be able to see basically there's metadata, all kinds of other goodies inside of there. Now here's the part that I care about, which is how do we actually serve it out? It says if you're not running on Colab, do some other things. But basically we want to run this, which will, I don't know what this is doing, but basically I think it's installing the TensorFlow serving software. And once that's done, then we can basically say apt-get install TensorFlow model server. And now, once we've got that, so it looks like, wow, that's pretty simple. So basically what it does is that you just give it the path to where the model lives. In this case, you would say TensorFlow model server. You would tell it what port you want to run on. You would want to tell it where the model actually lives, right? Which is the model base path right here, the directory. So in the other example, we probably would be able to build something like this. Look, here we can tail it. Uh-oh, it says something was wrong with it. Maybe let's run it one more time. Well, I'll have to play around with that later, and then you would do a request here. So this is a good initial step for me to learn a little bit more about what's going on here. So I think my homework, and maybe I'll do this next week when I come here, is I want to move past the fact that I created the model here. I want to serve it out and run it. And probably, I think what I'll do is I'll run it somewhere where I have more of a development-based environment. So this is a good first step here. I was able to use the TensorFlow extended to at least build out the structure. Now I need to do a little bit of homework and then serve it out with TensorFlow serving. So this is a good start to 52 weeks of live coding with MLOps. And if you're around next week, we'll serve this thing out. All right. Talk to you then.